Hi, in this video series, I'm going to show you how we at Solara Technical go about defining a complete power system. I'll post these videos every week on Thursday, so please watch for them. Today I'll be defining and picking our 48-volt DC power system. Continuing to design from the outputs back to the inputs, 9 DC to DC power express shelves need to be powered, as well as 1 inverter and 1 optical line terminal for a total of 11 known loads. So the power plant needs to support at least 11 load breaker positions. Referring to the Power Express spec sheet, we note the maximum input current is 80 amps. To eliminate nuisance trips, DC breakers are oversized by 25%. Where each load is divided by 0.8. For each Power Express shelf, the breaker is sized to 100 amps, or 80 amps divided by 0.8. The maximum input current for the inverter is 25 amps. The breaker used will be 25 amps divided by 0.8, or 32 amps. I'm moving this up to a standard size 40 amp breaker since there is no 32 amp breaker. The optical line terminal has 2 inputs. Each is 6 amps max. The breaker is 6 amps divided by 0.8 or 7.5 amps. The next closest standard size breaker is 10 amps. The system has a battery bank, so a low voltage battery disconnect is desired. When the battery bank is discharged down to a predetermined voltage level, an electromechanical switch or relay is opened. This disconnects the battery bank from the load, thus protecting the batteries from excessive discharges. All loads total to just over 360 amps. Allowing 24 hours for battery recharge, an additional 361 amps divided by 24 hours, or 15 amps, is needed. So the total available current needed on the 48-volt bus is 361 amps plus 15 amps, or 376 amps. The device used to convert AC input voltage to DC output voltage is called a rectifier. They come in various sizes. I'll define this system with the 50 amp units. The number of 50 amp rectifiers needed is 376 amps divided by 50, or 7.5 devices. Rounding up, we get 8 devices. For n+1 redundancy, 9 devices are needed. This means the plant picked must be at least 9 times 50 or 450 amps or greater in size. The integrated family from LTEC, now Delta, will work fine for this. DC plants have options for powering these rectifiers. Typically, there are 3 choices. Power an entire shelf, up to 5 rectifiers, from a single AC feed, or power 2 from a single feed, or power each rectifier with a dedicated AC power feed. I'll use 1 power feed per rectifier, known as individual feed. The plant supports a controller which handles alarms, voltage settings, current monitoring, temperature compensation, and communications, both local and remote. Since these controllers will measure current if shunts are also in the system, I'll define a battery shunt. I picked a 500 amp, 23-inch wide, rear-wired plant with 10 individually wired rectifier positions and 24 distribution breaker positions. It also has a battery shunt and a battery low voltage disconnect. Putting it all together, the rack looks something like this. The power plant on top, the optical line terminal, the current limiter power express shelves and fiber splitters, the inverter, and optional battery shelves if you wish to put a couple of the 7 required shelves here to help with floor loading. Thanks for listening. And if you need help with anything related to power, please reach out to us. It costs you nothing to chat. Until next time, have a great week.